Good morning, class. We're going to continue with the urinary system, and today we're going to start from the functions of kidneys. So basically, the kidneys plays a number of functions, but one of the most important, one of the three of the most important among the functions of the kidneys that it does includes one, formation of urine. It regulates water balance and urine output, as well as it regulates electrolyte balance in the body. So the kidneys form urine which passes through the ureters to the bladder for storage prior to excretion, which we described earlier on. The composition of urine reflects the activities of the nephrons in the maintenance of homeostasis. So there are times when urine looks to be concentrated, and that simply means that the nephrons in the kidneys, they are dehydrated. As a result, they cannot excrete enough urine, which explains that even the nitrogenous waste which are coming out, which are being filtered, are being removed through the urine. Waste products of protein metabolism are excreted. Electrolyte balance is maintained, and the pH acid base is maintained by the excretion of hydrogen ions. So when there is good urine output, that is when someone is taking enough IV fluids, there is maintenance of acid-base balance because the hydrogen ions are being excreted through the urine. Let us look at the first function, which is formation of urine. There are three processes involved in the formation of urine. These include simple filtration, also known as glomerular filtration. Then we have selective reabsorption or tubular absorption. Then the third one is secretion or tubular secretion. We start with simple filtration. So filtration takes place through the semi-permeable walls of the glomerulus and glomerular capsule. Water and a large number of small molecules pass through, although some are reabsorbed later. Blood cells, plasma proteins, and other large molecules are unable to filter through and remains in the capillaries. So we're saying filtration which takes place through the semi-walls of the glomerulus and glomerular capsule. Here the instance is to filter out some blood cells. So this glomerular capsule has small holes, what we call semi-permeable membrane. It has small holes which is able to filter out some small blood cells. However, large blood cells cannot pass through the semi-permeable walls of this glomerular capsule. Filtration is assisted by the difference. Filtration is assisted by the difference between the pressure in the glomerulus and the pressure of the filtrate in the glomerular capsule, because the diameter of the effluent artery is less than that of the effluent arteriole. A capillary hydrostatic pressure about 7.3 kPa, that is equal to 55 millimeters of mercury, builds up in the glomerulus. This pressure is opposed by the osmotic. So we're saying the filtration that takes place in the glomerular capsule is due to the pressure that is between the glomerular capsule and the glomerulus, and this pressure is about 55 millimeters of mercury, which builds up in the glomerulus. So the osmotic pressure of the blood, which is about 30 millimeters of mercury, and filtrate hydrostatic pressure of about 2 kPa, which is 15 millimeters of mercury in the glomerulus capsule. The net filtration pressure is therefore 7.3 in bracket 4 plus 2 is equal to 1.3 kPa, and the 55 minus 30 plus 15, which is equal to 10 millimeters of mercury. So if you remember very well, some of these, the hydrostatic pressure, which I explained earlier on when we were looking at the circulation of blood and cardiovascular system. We earlier mentioned this and we calculated this. We looked at how the hydrostatic pressure is being calculated, and what's about this pressure which contributes in the movement of blood in the blood vessels. So if you look at the 55 millimeters of mercury, which we described earlier on, which is capillary hydrostatic pressure, 55 millimeters of mercury. And if you look at the osmotic pressure, which is about 30 millimeters of mercury, if you subtract the two of them, you're going to find that their difference is about 15 millimeters of mercury. So this difference helps to bring about the filtration process that takes place in the glomerulus. The volume of filtrate formed by both kidneys each minute is called the glomerular filtrate rate, abbreviated as GFR. So what each kidney can filter out in 1 minute is what is called the glomerular filtrate rate. Glomerular filtrate, abbreviated as GFR, abbreviated as GFR. So in a healthy adult, the glomerular filtrate rate is about 120 mils per minute, i.e. 180 liters of dilute filtrate are formed each day by the two kidneys. So you can see that the kidneys really does a very good job in as far as filtration of fluids is concerned. About 180 liters of dilute filtrate are formed each day by the two kidneys. Let us look at selective reabsorption. Selective reabsorption is the process by which the composition and volume of the glomerular filtrate are altered during its passage through the convoluted tubes, the medulla loop, and the collecting tubule. So the cells which were filtered through the glomerular capsule, they get reabsorbed at various sites in the collecting tubes and the medullary loop. The general purpose of this process is to reabsorb into the blood those filtrate constituents needed by the body to maintain fluids and the electrolyte balance and the pH of the body. So like I said, in the first process, which we said filtration, filtration in the glomerulus. In the glomerulus, small blood cells are being filtered, and in the selective reabsorption, these cells which were filtered out, they are being reabsorbed back to the blood circulation so that they can maintain the electrolyte balance and the pH of blood. So depending on the need at that particular moment, the reabsorption of these cells may differ. It can be high or it can be low depending on the need for that particular moment. Active transport is carried out at carrier sites in the epithelial membrane using chemical energy to transport substances against their concentration gradient. So we are saying the reabsorption process is being achieved through active transport. It's being achieved through active transport. Some constituents of glomerular filtrate, e.g., glucose amino acids, do not normally appear in urine because they are completely reabsorbed unless they are present in blood in excessive quantities. I'm teaching.